Okay, so we're doing lesson number 10 in slope for Math 20-3. So today we're talking about rate of change. And rate of change is actually just another way to talk about slope. But what you'll notice is that it's always an amount versus time. So, and we're going to have different things happen. We're obviously talking about a constant rate of change if we're having straight lines. But for example, the first one, it could be talking about money in the bank. Okay, if you keep putting money in the bank, put the same away each week. You put $10 in your bank every week. Then every week that grows by $10. That would be your slope, and that would be your rate of change. So that would be an increasing graph. Okay. Sometimes things don't change that much, so the amount stays constant. So maybe if you have for your amount for graph 2, it's the amount of water in a tank, and we don't ever change. We don't take any out. We don't put any in, so it stays steady the whole time. And that would be our amount. Okay. Another example might be if we're driving our car. So this could be the distance traveled over time. We're driving at a constant speed. So that at every hour we travel another 60 kilometers and the graph goes up. Sometimes things are going to go down. So graph number 4. So it could be, this could also be dollars in the bank. You got a lump sum and then you have to pay your rent, right? Every month a certain amount comes out, your dollars value goes down in the bank. Graph number 5, something else going down. Say we're emptying a tank. So this could be a gas tank. As we drive, the amount of gas goes down, 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 down until it's empty. Okay, so it's always amounts when we're talking about rate of change. So some examples we had were bank account balance versus time, volume, so liters versus time. We see the pattern there. We could have distance traveled versus time. So this might be kilometers. There could be, we talk about, it's just, so it's an amount versus time, basically. Now, when graphed, the rate of change is equal to, and this is going to sound familiar, the slope of the graph. Okay? So that rate of change is going to be our slope, okay? Rates of change are going to have special units. So, for example, volumes of water would be liters per minute. And then we write that as a fraction, liter over minute. Now, that's going to be equal to the rise over the run. Aha, so that shows you how it relates to slope. Miles per gallon. We might write GAL, depends. So miles per gallon. Or we might also say MPG. Okay? And in that case, miles would be the rise and gallons would be the run. Distance over time, kilometers per hour. Right? Sometimes you'll hear it called kph, right? Distance over time. So in that case, the kilometers is the rise and the hours is the run. Okay, but you'll notice it's always time on the bottom and it's always the other amount on the top. Now, rate of change can be calculated to find one missing quantity when the other is missing. The other is given, sorry. So, the rate of change is going to be the quantity that rises over the quantity that runs. So it's always going to be an amount over time, right? For example, you might have the number of liters, so that's your volume, over the number of minutes. Now remember, way back we also converted units. Sometimes you might have to do that here, but right now we're okay. Example number 1. So, Ryan is a student who works part-time at a pizza restaurant. The graph shows his earnings over time. So we've got a graph. We see that he's obviously working a certain number of hours and he gets an hourly rate. The hourly rate, so his dollar per hour, is going to be the slope, right? So let's see, how does this work? It says, what is the slope of the graph? Well, we're looking at the rate of change, ROC. So it's going to be the gross earnings, the dollars, over the time in hours. Okay, so it's always that quantity rise over the quantity run. So if we look at our graph, the rise, it goes from 0 to all the way to 285. So this is our rise, and that's dollars. And our run, it goes from 0 to 30. And that's hours, and that is our run. Okay? So we just put that in, 285 over 30 hours. Now, if we want to know what his slope is, it's going to be $9.5 per hour, and that would be $9.50 an hour, and this represents his hourly wage. Now, you can tell from that how old this book is, because in Alberta, that's below the minimum wage, and he should protest that and say, hey, wait a minute, you're not paying me enough. Because just some information for you, that is well below the Alberta minimum wage. Now, from that, we can figure out his earnings for working different amounts. So our slope our amount is $9.50 per hour, and it says now how much would he make working 8 hours. So we just basically take $9.50 per hour and we times it by 8 hours. So let's do that math. 9.5 times 8, and we get $76. Okay, that's what he would make in that one day. Now you could also write that as $76 a day, but that's based on an 8-hour day. If he was working 40 hours in 1 week, he would have $9.50 an hour times 40 hours. So 9.5 times 40. So he would get $380 per week. Now that's based on 40 hours in a week. So if he got overtime or if he missed a shift, it would be a little less. Okay? Example number 2. Sometimes our rate of change changes. Okay? So we're looking at this. We have our distance versus our time, and our time is in minutes. And this is a transit bus traveling. So we want to tell a story about what's going on with this bus as it travels. So looking at this bus, we'll say, okay, so let's say in we got section A, then we have section B, we have a change. Section C, section D, section E, and section F. Now, if we have a flat part on there, that means that the distance is not changing over time. So what's happening with the bus is it has to be stopped. If the distance doesn't change, that means it's stopped. It's not moving. So let's see what's happening. So A, it's picked up all the kids and it's moving away from the school. Okay. B, we've now stopped. So we've stopped, and we've stopped for a few minutes. So maybe we're at the first kid's house. This is the kind of bus that stops right at your house. C, it moves to the next to the corner maybe. Now it doesn't stop for D. In D, it goes faster. So maybe it hit a road with a higher speed limit. So the bus driver's just gunning it, right? Okay. In E, if we look at E, in E, it does stop again. So maybe we came to another house. To drop kids off. And then in F, we continued driving to the next stop. Okay, so what you should notice is that if it's going up, if the slope's increasing, that means the bus is moving. If the slope in that section is 0, if it's flat, it has stopped because there's no change in the movement of the bus. Okay, how does slope number 1 compare to slope number 2? Well, or we're going to say slope number A compared to slope number B. Okay, so, or no, actually slope number 1, never mind, that's those places where it goes faster, right? So what we're talking about, slope number 1 is this one, slope number 2 is F. So we're comparing C and F. F is steeper than C, right? If we look at that graph, F is a lot steeper than C. So if it's steeper, then that means it's traveling faster. However, F is slower than D because D is steeper than F. So the steepest one is the fastest. So number 2, which we've called F, is faster than number 1, which is C, but slower than D. So comparing those steepness will compare how fast the bus is going in each section. Okay, now you have some practice to do. So you're going to do practice page 37. And you might also have a worksheet to do. So Mrs. Finley will give you those instructions.